Hi there, my name is Rones Friedman. I'm an IT professional and a science fiction writer. Welcome to Science Sci-Fi, connecting the public to science and technology through storytelling. Today, we'll do part two of a two-parts video series about the space race. Last week, in part one, we spoke about the original space race that took place during the 1950s and 1960s. Today, in part two, Space Race 2.0, what takes place right here, right now, today, and in the near future, in the coming decades. What's going on nowadays and how it will impact the future of our civilization. And as a bonus, I'll speak about the relations between the new space race and science fiction. I think you're going to have a lot of fun, so let's start with the presentation. Welcome back, everyone. Before we dive into Space Race 2.0, let's talk a little bit about the original first space race, the first space race between the United States and the Soviet Union. In the 20th century, we saw a huge continuous progress in aviation, from the first flight by the Wright brothers to the first transatlantic flights to the first jet, the first supersonic flight, and then in 1957, during the Cold War between the two superpowers, the United States and the Soviet Union launched the Sputnik, the first satellites in history, into Earth orbit. That caught the United States by surprise. Both superpowers want to show who was the bigger and more powerful superpower who deserved to rule the world, and the Soviets just proved that they are better in space, in a new arena. They can fly over the United States and there is nothing the US can do about it. Thus, launching the space race. The space industry progressed at a huge rate, almost at light speed. Like we had the first Sputnik, the first satellite, and the first animal in space, the first human in space, first spacecraft that had 2 people, 3 people, first spacecraft that was sent to Venus and to Mars, and eventually we had people going from Earth, landing on the moon, another celestial body, and coming back to Earth alive. Shortly after the first moon landing, the space race ended. It ended partly because the moon landing was very, very expensive. The Soviet Union couldn't compete. The United States showed that they can do it, but they saw no need to continue to invest huge amount of money in space. And also the Cold War started to wind down. There was a new agreement to reduce the number of nuclear weapons, the detente. The United States and the Soviet Union started to collaborate in space, which eventually led to the International Space Station. The characteristic of the space race, the original space race, that it was government funded and it was fueled by the Cold War. And what happened next? After the first space race, we enter a period of 50 years of stagnation in terms of space flights. Now, I'm not saying that there was a stagnation in space exploration. There were some very interesting missions, like the Hubble Space Telescope, the Voyager that went throughout the solar system and all the big planets. We had the series of Mars rovers that landed on Mars and did some exploration over there. So, but in terms of humanity's capacity to be in space, we pretty much stay the same since the end of the Apollo mission. Our total capacity to launch payload to orbit is about 500 tons to low Earth orbit. I'm talking about all the nations, all the countries combined together. It's no more than 500 tons. Humans remain confined to low Earth orbit. We can go to the International Space Station, and that's about it. And the cost of launching payload to Earth remain about $10,000 per kilogram. Or let's say if you want to launch 100 kilogram, it's about $1 million. You can see the picture here. It's me in the space shuttle. A space shuttle that was even more expensive in terms of cost. It was roughly $1.5 billion, and it could only launch 27 tons into low Earth orbit. It couldn't go to the moon. It couldn't go anywhere beyond Earth orbit. Right now, we are, in terms of a government project, we are in an interesting point because we kind of have a new race to the new moon and a new type, maybe perhaps of a Cold War. This time it's between the United States and China. Both China and the United States are committed to go to the moon. During the Obama administration, the plan was to land on the moon roughly at around 2028. Trump issued a directive to a more aggressive goal of landing on the moon in 2024. That, of course, requires a much bigger budget. But now, after Trump lost the election, Biden probably is going to return to the original Obama plan of landing on the moon at 2028, which will be less expensive. Of course, it will still be government run, and it will be used the SLS, the Space Launch System, which is a not very sophisticated. It's quite simple. It's based on the space shuttle, more or less the same. The fuel tank in the same. It's a bit stronger because it has to carry something above and slightly better boosters. It has a better capacity, but it still cost about $2 billion per launch, and it can only launch maybe once a year. So because of that, China actually have a chance of beating the United States to the moon, because the Chinese plan is also called for 2028. So this is kind of a space race fueled by a new Cold War. We'll see how it's progress. And now for the moment we've all been waiting for, Space Race 2.0. The new space race is dominated by SpaceX. This company is revolutionized. It disrupts the space industry. It was able to do the unachievable. It shows the world that a very well-run company, private company, can do a much better, a much more efficient job than any government around the world. But Space Race 2.0 didn't start with SpaceX. It started actually in 1996 with the Anastasis X Prize for reusable orbital spaceflight, suborbital spaceflight. In 1996, the foundation decided that to issue a challenge that the first human person or entity or company or group of people that will be able to launch a spacecraft to space, and not to orbit, just to suborbital space, land it safely, and then within 2 weeks, launch it again and land safely, will get $10 million. So that was the challenge. In 2000, Blue Origin was founded based on the Delta Clipper. The Delta Clipper was a NASA project, a single stage to space. That's a spacecraft that don't have multiple stages like traditional rockets. And of course, reusable. NASA stopped developing the project, and Blue Origin, that was founded by Jeff Bezos, the same one from Amazon, decided to build another spacecraft that is based on the same concepts. In 2002, SpaceX was founded. 2004, the X Prize was won by Spaceship One, which was built by Burt Rutan, a famous aviator, funded by Paul Allen from Microsoft. And eventually, the Spaceship One concept was bought by Richard Branson, who founded a company called Virgin Galactic, and perhaps very soon, maybe early next year or in a few months, a new version of this same spacecraft called Spaceship Two will launch people into suborbital spaceflight and land them back safely. So that's going to be a very interesting one that's happened. And then 2008, SpaceX Falcon 1 was the first private rocket that was able to reach orbit. 2010, SpaceX developed this Falcon 9. That's a bigger version of the Falcon 1 that used the same engine, but 9 engine instead of 1. Now, the development time took about 1/3 of the time, and the cost was about 1/10 when compared to a traditional company that developed rockets that was designed to go to space. So this is started to show how revolutionized SpaceX is and how different Space Race 2.0 is from the original space race. It's much faster development time and it's private and it's a lot cheaper. So we can do a lot with it. But Space Race 2.0 is not over until 2010. We had the first Dragon, SpaceX launched the first Dragon capsule. It still not didn't carry humans, but it carried payload and cargo to the International Space Station. Then, 2015, a huge milestone, again by SpaceX. The first ever first stage booster landed back on Earth. So we have a rocket that have two stages, launch into space, and the first stage was able to turn around, come back, and land and reuse. And reusability is a huge factor to improve, to reduce costs. 2018, SpaceX Falcon Heavy. That's a super heavy launch system that launched a Tesla car, you see the picture, don't panic, to a trans-Mars orbit. That I saw the video when it happens on the day that it happened. It was very exciting to me. 2019, SpaceX Starhopper test. Now SpaceX are working on a new kind of rocket, a revolutionary rocket, huge rocket that will be 100% reusable. So this was the first iteration. They managed to use a new type of engine, the Raptor engine, and that used new types of fuel. And they did a small hop, 150 meters, to demonstrate that it's working and it can be launched and land. 2020, May, SpaceX first human mission from a commercial company, the first company that was able to launch humans to space, to the International Space Station. That was a demo flight. And right now, in November 2020, there was another launch of the Dragon 2 capsule. This time it carried 4 astronauts. This is the first time that one capsule was able to carry 4 astronauts. Up until then, it was only, even the Apollo only carried 3 people. Of course, the space shuttle was able to carry 7, but this was still a huge achievement for a private company. And then we had Starlink. Starlink is a constellation of communications satellites in orbit around Earth, able to provide internet connection. And right now there is a beta testing. There are already a few hundred satellites in space from this constellation that was launched by SpaceX. And if you live in North America, you can register and get an antenna and get internet connection. The characteristic of Space Race 2.0. Even today, before Starship, before the future, just the beginning of the Space Race 2.0, launch costs had been reduced by a factor of 5, from $10,000 per kilogram to less than $2,000 per kilogram. That's a big, but that's not the end of it. It's going to get a lot better and a lot cheaper. Another characteristic of the space race, it's privately run. It's not big government organization that hire companies to do and give them the design and tell them exactly what to do in a cost plus project. Instead, we have private companies that develop spacecraft on their own, and then sometimes government are their clients, and sometimes they have other entities and other companies are their clients. These companies are mostly owned by billionaires like Elon Musk, who is the owner of SpaceX, Jeff Bezos, the owner of Blue Origin, Richard Branson, the owner of Virgin Galactic. We already spoke about that, but it's not restricted only to billionaires. Like if you have an engineer that is very talented and he can find investors, company could be owned by regular engineers like Peter Beck from Rocket Labs in the picture here. The idea all these people had is to create a positive future when humanity is able to become a spacefaring civilization and able to launch payload to space in large quantity and cheaply while making money. We've reached the science fiction part of the presentation. Space Race 2.0 was influenced in part by science fiction. And I'm talking about Elon Musk. What motivated him to start SpaceX, why he wanted to do it at all. So I'll start with Don't Panic. That's, of course, a quote from Hitchhiker Guide to the Galaxy by Douglas Adams. If you remember the Falcon Heavy launch that launched the Tesla to Mars, it has Don't Panic in it. So don't panic if you do that. Dragon capsule was named, at least according to SpaceX CEO Elon Musk, after the 1963 song Puff the Magic Dragon by Peter, Paul, and Mary, reported as a response to the critics who said that the private company cannot do a space capsule like he did. It was an impossible project and he decided to do it anyway. But the main reason, the main issue why we having this slide at all is the Foundation series. The Foundation series, that's a book series from started in the 1950s by Isaac Asimov. In it, it's talking about a galactic civilization that at some points, due to some historical events, had collapsed. It's kind of a little bit loosely based on the Roman Empire that collapsed. But what happens over there is that one visionary, Harry Seldon, knew in advance that at some point the civilization was about to collapse, and he decided to build a colony on a remote planet, build some sort entity that he called the Foundation, that will preserve all the scientific knowledge of the galactic empire and perhaps even advance it even more. And there will be the core, the kernel, the source that will ignite and start and restore the civilization to the galaxy. So the idea is that Earth is not safe and our civilization is not the most stable civilization right now. We've seen, and there is a chance it will collapse. Actually, there is a very high chance, 100% chance it will collapse at some point in the future, and even humans will become extinct, but there is a chance it will happen in the near future, within a few decades, or perhaps even in this century. The idea that Elon Musk had is to build a colony on Mars and perhaps in other solar places in the solar system, big enough with at least 1 million people, and advanced enough that in case something really bad happened to Earth, of course, we don't want that and want to take action to prevent it. But if it happens, then it will not be the end of humanity. There will be some humans elsewhere that will be able to come back to Earth and restore and recover our civilization. So that was the motivation that inspires Elon to start SpaceX to begin with. So thank you, Isaac Asimov, and thank you to anybody who decided to become a science fiction writer. SpaceX history. Elon Musk, after he sold PayPal, he had $305 million. Back then, he already he wanted to inspire humanity and inspire NASA to have a Mars mission. He thought that launching people to Mars and eventually build a colony is extremely important for the future of humanity. So his goal was to build something called the Mars Oasis, that build a very little greenhouse with some plants and animals and send them by rockets to Mars, land them on Mars. And the idea was this will inspire NASA. And they say, oh, launching humans to Mars is a very good idea. Let's do it. And thus advance humanity. But US rocket was very expensive. Elon flew to Russia. The Russians were greedy. They also gave him a very high price. So on his way back on the planes, he did the math, the calculation, how much energy costs, like in fuel, to launch payload to orbit. And he saw it actually not very expensive. If you just had something like space elevator and use electricity, it's about $3.5 per kilogram. But if you need to buy fuel and using the rocket expense equation, which means you need a bigger rocket, then the cost of humans is about a little bit more. And perhaps, so the cost per fuel to launch a person that costs 100 kilogram, a human plus a luggage and a little bit payload, it's about $72. So if it's only cost $72 in fuel, why is it so expensive to fly into space? Why a flight from Los Angeles to Sydney costs $2,000 and a flight to the International Space Station, 150 kilometers above Earth, costs $200 million? Both consume a similar amount of energy. Why the price gap? So we already know it's not the fuel cost, it's something else. So the conclusion or the idea is that there are two problems why flying to space is so expensive. One is technical issue, reusability. And all the rockets we had up until now were expendable. It means you launch the rockets, you want to launch again, you need to build a new rockets. If you had to fly from Los Angeles to Sydney and we have to build a new airplane every time we fly, then of course a flying ticket wouldn't be $2,000. It would be a lot more expensive, perhaps in the millions. So we need to make a rocket reusable. And then that way we can go closer that the actual cost will be not exactly the cost of fuel, but not much more. Perhaps similar to commercial flight right now. And another issue was constitutional. Government agency, the way they manage projects is not the most efficient project. And somebody who came from Silicon Valley and ran commercial companies in Silicon Valley and know new project management method, perhaps can do a better job. Lean versus agile. In 2009, Obama canceled the moon program because developing a heavy booster would calculate to take 12 years, and the cost was supposed to be something like $36 billion. I'm talking about the RS-5 and the RS-1 projects. The RS-5, that's the heavy launch system that you see in the picture below. So it was canceled. But SpaceX was able to build the Falcon Heavy. It was slightly less capable, maybe perhaps 70%. It can launch 64 or 65 tons to low Earth orbit. But the development time was half. It was only 6 years. And the cost was maybe 1/70th, maybe 1/30th, 30 to 70 times cheaper. It cost about $500 million to develop, not much less than 36 billion. And the development of the Falcon Heavy started in 2011, and in 2018, it was launched to Mars, flew. Each flight cost about $150 million. And it's 75% reusable. You can land the two boosters from the side booster and also the central booster. I think it failed on the first try, but theoretically you can land it too. So only the upper stage is not reusable. And if we talk about the next generation of spacecraft that SpaceX is building, the Starship that you can see on the picture here on the top left, on the top right, Starship, this is going to completely revolutionize the space industry. It will be 100% reusable. It will be extremely cheaper, and it will be able to launch about 150 tons to low Earth orbit. NASA, on the same time, is developing now the SLS, the Space Launch System. So far, it cost $14 billion. I believe now maybe a little bit more, maybe 15 or $16 billion. And it's supposed to fly before the end of 2021. Like originally, it was supposed to fly 2016 or 2017. It was delayed. I'm pretty confident it will not fly in 2021, perhaps 2022. but price is going to be extremely expensive, and Starship is going to be a huge revolution. Let's talk about a little bit about cost plus. That's the way NASA was conducting a project in the past, and that's how they are conducting the SLS project right now. I'm not saying it's always an extremely bad idea, cost plus, but it is pretty bad idea right now. It could have some advantages in some cases where the expense is supposed to be huge and it's not economical, and the only way to produce a project is by using this method. But what cost plus means? It means NASA is giving a company, I want you to build XYZ, whatever it costs you, it's fine. We're going to pay you whatever it costs you, plus a little bit more. So you will have a little bit of a profit. So when a company get this kind of offer, what they do, they want to inflate price, but as much as they could possibly justify. Overhead is queen. The most important way to make profit is to have more expenses. The more expenses you have, the more profit you have, because typically it's something like 8 to 10% the cost. So if it costs $1 billion and you get 10% of that, that's $100 million. But if it costs $10 billion, you get $1 billion. You want to inflate price. If you go, for example, to the supermarket, you don't care how much it costs to grow up a banana and bring it to the supermarket in the United States or Canada. You only care about two things. You care about how much it costs and what is the quality. How much it costs to manufacture, you don't really care. But in cost plus, they do. So the aerospace industry that use cost plus method right now, they have 13 administrators for every worker. In SpaceX, they have like 0.2 or 0.3 administrator for every worker. And additionally, space cost plus, because it is very expensive, the companies develop it, and also NASA, who issued this project, they don't want to take any risk. If launching, and because it's super expensive, if launching a satellite costs $400 million, we don't want cheap satellites. We want very expensive, reliable satellites. So paying additional 20 million or even 50 million to have a slightly more reliable satellites makes sense under this condition. But if, let's say, it costs $1 million to launch, then it may be perhaps not worth to pay additional $50 to have a 1% more reliable satellites. So this is why the private sector right now that is moving away from cost plus, this is a huge advantage and a huge way to reduce cost of launching payload to space. What's next? Next week, we are going to talk about Starship, the next generation of SpaceX spacecraft, which is going to completely revolutionize the whole space industry and even the future of humanity. And what kind of things we are going to do thanks to it, to having such a wonderful spacecraft, which means we're going to develop a lot of industry on Earth orbit. We're going to have a base on the moon, a colony on Mars. We're going to mine the asteroids and perhaps do a lot more. But we're going to talk about it next week. So just a quick summary. The difference between the stagnation that we had in the last 50 years and what is happening and about to happen right now with Space Race 2.0. During the stagnation, we could only launch 500 tons per year to low Earth orbit. Us means the entire of humanity on this planet. Humans remain confined to low Earth orbit, and the cost of launching payload to low Earth orbit was about $10,000 per kilogram. In SpaceX 2.0, instead of being able to launch only 500 tons, we'll be able to launch tens of millions, perhaps 10 million tons of payload to low Earth orbit per year. And humans will be able to colonize the moon, Mars, the asteroid belts, and perhaps a lot more. And the cost of launching payload to low Earth orbit is going to be a lot cheaper than $10,000 per kilogram. And don't forget, Space Race 2.0 was inspired by science fiction. We want to have a bright future. We are going to talk a little bit more about it in our next video next week, and about all the plans that are about to occur in the next couple of decades. And thank you very much. We have hopes. I hope to see you in the future. We are right now seeing the beginning of a new space race. Did you like the video? If you do, please don't forget to subscribe and hit the like button. Thank you very much, and see you in part 3 next week.